Goss Newspaper Products, with Paper Converting Machine Company and the Washington Post, currently are testing the Flexo process in a production environment to determine if Flexo can be adapted for high-volume daily newspaper production. Our testing and evaluation is designed to answer the question about flexography that has been raised with increasing frequency in recent years. Is Flexo a better process for newspaper production? Included in that question are the issues of good print quality, lower operating costs, elimination of ink rub-off, reduced noise and energy levels, and less capital investment cost. Today we don't have the answers, but we believe they will be provided by our comprehensive evaluation, which is being conducted on an 8-unit letterpress converted to Flexo at the Post's Northwest plant. This is an environment which cannot be duplicated in any laboratory. The objectives of this project are to assess Flexo on a full press basis, determine if a large-scale newspaper plate room can consistently produce Flexo plates within tolerance standards, test the sensitivity of impression variation on print quality during long runs and from unit to unit, determine if ink density variation can be controlled, evaluate the operation and maintenance requirements, test the supply and auto wash-up systems with fast-drying, water-based inks, and, ultimately, compare the economics of Flexo to letterpress and offset. The testing has 2 phases. First, a letterpress unit from the Post was converted to flexography at the Paper Converting Machine Company in Green Bay, Wisconsin. That firm designed the Flexo inker. Conversion of the L letterpress at the Washington Post began last June. The first unit was completed in November. Startup of the full press began in April 1985, and since then, it has regularly been printing saleable pre-date sections with processed color. Runs with up to 7 webs have been made. The processed color results have exceeded expectations. The Flexo process begins in a new plate room, which is dedicated to the production of plates for the Flexo press. Plate evaluation is critical to the project and is focused on dimensional quality, physical properties, relationship with ink and newsprint, plate processing equipment, and registration. 2 types of Flexo relief plates are being produced. One has a metallic substrate and the other a clear mylar. The metal plates are used on 7 Flexo units with new magnetic lockups, while 1 unit is equipped with a lockup for mylar plates. The processed metal plate, in this case a W.R. Grace Letterflex plate, is punched with alignment holes. Then it is punched with the 4 plate registration holes. A round hole and an oblong hole are punched in the leading edge of the plate. The trailing edge has slightly oversized holes. These are used only to guide the plate and reduce skewing. The registration holes are located in a slight depression created when the hole is punched. The magnetic plate lockup has proved to be fast, easy, and extremely accurate. It should be highly beneficial to the industry. The leading edge holes are placed over the registration pins, and the plate cylinder is rotated. The trailing edge fits over the pins, assuring correct plate location. Color half-decks are also quickly plated from the aisles between the units. The second type of plate we are currently using in our evaluation is a Hercules Mylar plate. This clear plate requires bends in both the leading and trailing edges. The plate is trimmed and punched with alignment holes. Then, registration holes are punched. Finally, the leading and trailing ends are bent so they can be attached to the plate cylinder lockup. Nap plates are also being tested during our evaluation. The results show promise, and we will conduct extensive tests of these plates later this year. After the plates are punched, the registration of the color plates is verified on this equipment in the plate room. Each side of the plate has a registration dot, which appears on the verifier screen. The two dots are bracketed by the adjustable white lines. The next plate, in this case a process red plate, is placed on the table. When two dots fall within the grid, we know the two plates are in register. This procedure will prevent inaccurate plates from reaching the press. While the plates are being processed, punched, and verified, the press crew measures ink viscosity with a number 3 shell cup. The ink tanks and pumps are located in the reel room. Feed hoses transport ink to the printing couples, and drain hoses return it to the system. If an ink problem occurs, a warning system lights an indicator on the unit and sounds a horn. The Goss Flexo press has 19 Analox rollers, 2 per unit and 1 on each half deck. The Analox roller is critical, and we are evaluating cell pattern, the volume of cells, surface material, cell generating process, as well as cost. The Analox roller is enclosed by a pan. Ink is supplied to the center of the doctor blade holder. The doctor blade smooths the ink over the roller surface. Excess ink collects in the pan and is returned through the drain hose back to the unit ink tank. The doctor blade holder can be rotated away from the Analox roller for cleanup or blade replacement. In the operating position, the doctor blade is air-loaded against the Analox roller to provide uniform pressure across the surface. Wash-up of the Analox roller after the press run is fully automatic. The Analox roller is flushed with recirculated water, followed by a clean water spray. A separate clean water flush hits the doctor blade, which is applied to the Analox at regular intervals. The wash water goes down the drain into a holding tank. The post has obtained permission to dispose of the diluted non-toxic inks directly into the sewer system. Each Flexo unit has a programmable controller located under the unit housing. Controls are flush-mounted buttons. Each printing couple and half deck has a bank of controls for the inking system, Analox roller rotation, impression, doctor blade, analog throw-off, and wash-up system. The press is operated from a master switch, which controls automatic startup and shutdown sequences. Each color printing couple has side lay and circumferential register adjustments, with readouts displayed in thousandths of an inch. During our prototype unit testing, ink dry-up was not a problem because suppliers have developed re-wettable inks. Likewise, ink flow and viscosity control have not been a problem. Bulk ink handling is still being evaluated. An auxiliary drive has been installed on the Analox roller to prevent ink drying. This drive is activated when the press is stopped. The roller continues to turn and the ink pump continues to supply ink. During our evaluation, many questions are being answered, but some major issues are still unresolved. One is print quality, particularly problems created by the fill-in of halftones. We believe this is primarily due to inks, plates, and paper. The next step is to test and evaluate new materials. When that process is completed, we will then begin to analyze all production data. The results of that analysis should provide the answer to the question, is flexography a better process for newspaper production than letterpress or offset?